So for today's explainer, we're doing something a little different. Our source material isn't an article or some dry study. Nope, we've got our hands on the raw, unfiltered audio from one of the most incredible engineering projects you can imagine. We're going to use the actual voices of the crew to tell the story of how they built a massive bridge over what many called an impossible canyon. Okay, let's just jump right in.
And boom, just like that, you're on the job site. This one single command, pulled from hours and hours of communication, it just sets the tone perfectly, doesn't it? This is a story about huge power, constant, life-threatening danger, and the absolute need for human precision when you're up against the forces of nature.
So what's the big problem they're trying to solve? This enormous, unforgiving canyon. Just a massive, gaping void that these engineers had to somehow span. You know, building a bridge here wasn't just seen as difficult. A lot of people thought it was pretty much impossible, a truly monumental feat to connect two landscapes that were otherwise totally cut off from each other. And a feat like that, well, it takes a monumental investment. $300 million. I mean, let that number sink in for a second. It tells you everything you need to know about the scale of this thing and the stakes. This was not just another construction project. This was a massive undertaking where failure was simply not an option. Okay, so you've got the money, you've got the canyon. Where do you even start? The first, and maybe the most terrifying phase, is just conquering the empty space itself. How do you begin to build something when your foundation is literally nothing but air, hundreds of meters above the ground? This is where the real journey begins. So how do they do it? Well, it's kind of like this three-step dance across the void. First, they have to string a very thin but incredibly strong pilot line all the way across. Then they use that one little line to pull the massive, heavy main cables into place. And only after those giant cables are secure can they build the first, terrifyingly narrow walkway for the crew. I mean, can you imagine being the first person to walk across that? You can almost feel the physical strain in that voice, can't you? We are talking about forces that could snap these thick steel cables like they were toothpicks. Every single millimeter of alignment is absolutely critical. A tiny mistake, a tiny misalignment here could domino into a total catastrophe. The precision has to be perfect from the very first pull. And then, on top of everything else, you have this constant, invisible enemy, the wind. And when they say wind shear, they're not just talking about a strong breeze. Oh no. This is a sudden, violent shift in wind speed and direction that just whips through the canyon without warning. It's a twisting force that can throw multi-ton pieces of equipment off course in a split second. And the crew's job? Just hold steady against all that chaos. So once those main cables are finally in place, the whole project it transforms. It becomes this meticulous, high-stakes assembly job. The team begins the incredibly slow, deliberate process of hanging the bridge deck, one massive piece at a time. They are literally building a puzzle in the sky. Okay, before we go any further, we gotta understand this key engineering term, deflection. Now, stick with me here. In simple terms, it's just how much the bridge is designed to bend or sag under its own weight and, the future weight of all the traffic. Managing this is one of the most critical parts of the entire build. Too much deflection and the whole thing could fail. And this command right here illustrates the goal perfectly. Hearing the crew on the radio confirm minimal deflection, well, that's a huge moment of success. It's proof. It means their math was right, the materials are holding up, and all those puzzle pieces are fitting together exactly the way they were designed to, high above the canyon floor. This slide, for me, this is what blows my mind about the whole thing. It shows you the most incredible contrast of the entire project. On one side, you've got the massive scale, a structure spanning hundreds of meters, a true giant. But then you look at the other side, and you see the unbelievable reality of the work. The total tolerance for error, the wiggle room for alignment on this giant structure, is just 2 millimeters. That's less than the thickness of 2 credit cards. And here it is in action. See, that's not just some theoretical number on a blueprint, it's a real-time measurement that the crew is constantly checking. Being off by just 2 millimeters, as this callout shows, is enough to stop everything for an immediate fix. The big takeaway here is that this absolute megastructure is being built with microscopic precision. It's just incredible. Building it is one thing, but that's only half the battle. Once it's all put together, the bridge has to go through a whole battery of intense tests. This phase is all about proving the structure isn't just standing there, but that it's fundamentally safe and ready to handle decades of cars, trucks, and whatever nature throws at it.
So this bridge is wired up with thousands of sensors, which creates what is basically a digital nervous system. As this table shows, they monitor everything in real time, from stress and tension to how much it expands in the heat. And you can even see how detailed it is. They flagged minor corrosion on cable 72. It's like a constant 24/7 health check.
Remember the wind, that constant enemy? Well, this is where all that brilliant engineering proves its worth. This chart shows that during testing, the bridge got hammered with winds peaking at 100 kilometers per hour. But as you can see, that's well within its maximum design tolerance of 150. The structure performed exactly as it was supposed to. It passed the test. And check this out. This is modern maintenance in action. A drone flying by spots something tiny, minor corrosion, and boom, immediately another drone is rerouted to go get a closer look. It just shows you this proactive, high-tech approach where no issue is too small. Every potential problem gets investigated right away. So after months of construction and weeks of these grueling tests, the moment finally arrives. The data's all in, all the checks are complete, and the structure is declared sound. The puzzle is solved, the void has been conquered, and this bridge, well, it's ready to be born. This right here, this is the final sign-off. It's all spoken in that clipped, professional language of the engineers. Phrases like, all centers greened, and performance is nominal, just mean one thing. Every single check has been passed with flying colors. This isn't just a structure of steel and concrete anymore. It's a fully operational, stable, and ready system. And after all the technical jargon, all the tension, and the immense pressure, you get this, a moment of pure, unscripted human joy and relief. The final piece is set, and for the first time, you hear that professional calm just break into a cheer. That woohoo, well, that's the sound of victory.
And that leaves us with this final thought, doesn't it? We've just listened to a team conquer a massive physical void. It really makes you wonder, what other impossible canyons, in science, in society, maybe even in our own lives, what could we cross if we brought this exact same level of focus, collaboration, and millimeter-perfect precision to the challenge?